open up a new Colab notebook, go to colab.research.google.com, and then go ahead and click on the new notebook option. This is going to be an overview of an introduction to the Pandas library. We're analyzing big data here. So the first thing we need to do is get some data. Now, a standard way to do this is to look up CSV GitHub files. There are many other ways. Let's take a look at this one. You can search topics on Google. You can also go to ones you might know. I have some CSV files on GitHub on Berkeley Coding Academy. So if you search that, you should see this link. This is me, Corey J. Wade. We'll go ahead and click on it. And you can see down here, BCA datasets. This is what I'm looking for, BCA for Berkeley Coding Academy. And here are some different datasets on here. We could check out any of these. I'm gonna go with the student Portugal dataset. So if you find a CSV file on GitHub, click on it to open it, and then you need to click on this raw option. It does not work as is. So we're gonna click on raw. This is the dataset. This will work as a hyperlink. Hit Command C. Let's copy it, go back to your Colab notebook, paste it in as the URL inside of quotes. It is a string, okay? Now, what we're gonna do is we're gonna read this into the Pandas library. So we're gonna import Pandas as PD, and then we are going to save it as DF, a data frame. Okay, DF is short for data frame. So what we need to do now is make a link between that URL and the Pandas library. Let's call it a read file. So we go into the Pandas library PD, and then dot. This allows us to use all the methods within Pandas. And I want read underscore CSV. You can read other kinds of files. CSV is the standard, stands for comma separated value. Put in the URL, okay? And now we want to see the data to ensure that it looks as expected, and we can use a method on the data frame, which is df.head. Okay, these 4 steps are very standard. Let's give it a try. Press Shift Enter to run the code. You can see it shows up here, Colab is connecting. And while it's connecting, we can change the title to Pandas Intro. Okay, now this is not right. It looks blank. And you know, it depends on how it's actually stored. If you actually looked at the data set here, you can see it's actually separated by semicolons, not commas. So Pandas has a lot of options for sort of fixing CSV files that haven't been stored properly. And one of them, you can put in this separator parameter. We need this here. And it's not separated by commas as it should be, but by semicolon. So you put the semicolon in there. Now look carefully at the difference, okay? Go ahead and make that change. Press Shift Enter. And now you can see we have an actual data set. It looks good. Okay, what can we do with this data set? We can do lots of things. First thing you want to do is just get a look at it. You can see school, sex, age, different columns. It's good to go all the way to the right. There's some columns that aren't showing. We can take a look at how to fix that. Sometimes you might know something about the data set in advance, like that this is about student grades, G1, G2, G3. If you're ever not sure, you can always go back to the source of the data. Where did you get it from? Is there any other information here? In this case, I believe that there is not, but I can tell you this was taken from somewhere else. It would be helpful to have that information. You can find data sources if you don't have them directly through searching on Google to try to get more information about what the different columns mean. Okay, you want to be able to kind of understand these columns. So let me show you some standard tools that you can use. So DF, first of all, it is a data frame type. Okay, we saved it just as DF, but if we check the type, this is Python, you can see it is a data frame, specifically a pandas.core.frame.dataframe. Okay, that's fine. Well, what can we do with this? df dot, we get the methods of the data frame type. And it's showing some different things that's interesting. If you scroll down a little, you'll see a lot more. There's really a lot. Let me show you two of my favorites. df.info, okay, with parentheses. This is a method. And you can see what it does. It gives you some critical information about your data frame. Like this one says, hey, it's got 649 entries, which are the rows. So that's the total number of rows. It's showing us the data frame type, okay, of each individual column. Objects are often strings. We want integers and floats for machine learning. And it shows us non-null. This is nice to infer that we don't have any null values in this data set because we have 649 non-null values. So this is a clean data set as is. Another method that we can use is df.describe. Okay, so put that in there. Another method, use parentheses, press Shift-Enter, see what you get. And you can see that these are the descriptive statistics. Okay, it's worth taking some time to look at these. Let me zoom out just a little bit so you can see a little more here. The age is one of the columns, and it's showing us the mean age of the students here is 16.7, and they range from 15 to 22. This only works for the numerical columns, like the grading periods, right? We see the range is from 0 to 19, so they're using a different grading system than we are. This must be the mean, right? Mean. So we've got the mean grade is 11.39. And we also have the median here, which is the 50 percentile. Okay, and this is the 25 percentile, which is sort of the median of the first half. That means if you put the data set in order, the first 25% of the data is between 0 and 10. The second 25% is between 10 and 11, actually. And the middle from 50 to 75% is between 11 and 13. And the last quarter is between 13 and 19. So that's what these numbers mean on the side. These are all, in effect, medians. The standard deviation goes with the mean. It's how much you would expect the grades to be off, or in this case, the age from the mean. About 1.2, a couple standard deviations is the norm. This data is not normally distributed, but you can always compute the standard deviation. In a normal distribution, 3 standard deviations are within like 99% of the data. Okay. So those are my two favorite methods, df.info and df.describe, to sort of look at the data frame as a whole. If you want to see the last 5 rows of the data set, that's df.tail. Okay, tail like .head gave us the first 5. df.tail gives you the last 5. What if you want to look at, say, the first 20? Well, inside of head, you could put in like 20, and then it's going to show you the first 20 rows of the data. Okay. What if you want to have a random sample? Okay, let's show, how about 20 random rows of data? This could be useful. It's df.sample, and then inside of sample, you want to put 20. Okay, now if you look on the left here, we see different indices. Okay, so these are not in order. Okay, this is very useful to sort of downsample your data. And if we wanted, say, something like, just give you an example, a smaller data set of 100 rows, well, then you would simply save it potentially as something different, like df100, and then we could do df sample, like get it random 100. So now it's saved as a new data set and data frame, I should say. And now you can look at, say, the first 5 rows of your new data frame. Okay, so this is one way that you can sort of navigate your data frame. Like you can make it smaller. You could also, let me show you how to look at individual columns and how you can deal with that. Like maybe you want to look at just a certain age group, for instance. Well, first let's look at this. So so value counts, and this is designed to be by column. Okay, so we haven't talked about how to access a column. We've talked about how to access the whole data frame. How do you access a column? Let's take a look at that. Well, df, the standard is actually to put in brackets the name, which in here I have an age column, right? And you can see if you start typing, Club will give it to you age. You only want the one quotation. Now, if you just press Shift Enter, it'll show that column. But kind of nice, like this .describe method, you can like get it on an individual column. And so there I can see the descriptive statistics of that column. Similarly, if you wanted something very specific, like let's say you just wanted to know what the mean age is, you might wonder, is there a dot mean? And let's find out. Go ahead and enter the code, press Shift Enter, and you can see that you can also get it like that. So this is the standard way to access columns, and you can order or you can find the values of each, how many people are each age by putting it into this value count. So I hit Command C, that was the Command V. This was this data set. I want to go ahead and copy in that column name, put it in here, and then let's take a look at it. And you can see now it's showing you basically how many students are the different ages, okay? So that's kind of nice. You know, we can, and maybe you want to just look at like first years, like students who are 15. Okay, well, how would you do that? All right, so there's something nice in here, which is called conditional formatting. And basically what you can do is inside of the brackets, you can give a specificity about that, you know, like this column. Like we want to just limit it, okay, to DF age, right? We want this to be equivalent to just 15, okay? So what we have here, we're taking the whole data frame, but we're looking at a specific condition. That condition you can put inside of the brackets. And so now if we press Shift Enter, you can see it's only showing kids who are of 15. And if you wanted to work with this data set, of course, you can use it like this. But again, you could save it, DF age 15 or something, I'm not sure. And then now it'll limit it just to this case, okay? And you can learn everything you want to about that data frame, okay? So that's another nice way to sort of limit your data frames. And again, let me highlight what this does here with a comment. Reduces DF to ages of 15. So really nice, called conditional formatting. Maybe let's practice one more. You know, if you want to see your columns, you can just type df.columns, I think, plural. You can see plural, right? This would not have parentheses because it's not running a function on it. The information's already there. And you can see here are the different columns in the data set. So I think only a few of them were actually missing. And so if we wanted, you know, to get more information on this, like let's say we want to look at like students from the first grading period who struggle or something. And so we could look at DF such that what? Well, how about DF period G1? And maybe we want to look at students that got just less than 10. Okay, recall that their grades go from 0 to 19. Okay, so this is the condition I'm imposing on it. And if we look, you can see it's reduced because it's showing you the different indices. If you go to the right, looking at the first grading period, you can see that they are all in fact under 10. Okay, and it does tell you that this is 157 rows of the data. Okay, so that's sort of an introduction to how you navigate kind of through pandas. I will conclude with one big one, which is called loc and iloc. But first, let me just put a note here. Limit DF to G1 period of grades less than 10. Okay, so what's this .loc and iloc business? So .loc gets you data by rows, okay? So df.loc, what? Okay, what's the location here? Well, here the rows are actually indexed, okay? So the labeling is the same as the numbers, okay? So what you can do, for instance, you could say, I want rows, say 100 to 110. That will do it. And then what columns do we want? Well, the idea of location is that you can use them by name, okay? And so by name, everything's in bold, it's by name. Maybe we want just G1, 2, and 3. Okay, well, this uses standard Python slicing. So what you would do here is you would put in G1, okay, going all the way up to, and then loc, I believe, will include because you're naming it G3, okay? So my expectation here is that show rows, it's row comma column, 100 to 110, and columns G1 to G3. Okay, so let's press Shift Enter and see if that is what we get. And you can see that it is. And if you look, it does include 110 and it does include G3. This is different than regular Python where the last number is excluded, but these are not numbers, these are names. The idea is you're using them by name. So I will make another note here. .loc is by name. Let's now look at iloc, which is by index. Okay, we're gonna do the same thing. So df.iloc, index location. Well, the indices would be the same because again, the numbering is the same, but it will actually exclude the last one. So you would go up to 111 if you want to get 110. And if you know it's the last 3 rows that you want, you would start at the negative third, okay, and you go all the way up to and including everything to the right. So this should deliver the same subset, and you can see that it does. Okay, so .iloc uses, so this is slicing by index. I think of it by number. Slicing by index, you know, numbers, and this is sort of like up here, this is by names. Okay, by name. And I will sort of stop there, but you'll get more practice with this because if you're just thinking about how is it that you want to access the different sort of parts of your data, it's many times you're going to know it by the index location, by the numbers, but in some cases you want to actually access it by the individual name.